Hi, today we're going to talk about something called complement of a set. So when you have problems that involve complement of a set, there's got to be something that we call universal set, which is the set that's going to include all the other sets and elements for a particular problem. Please understand the universal set may vary from problem to problem, so it's not something that's set in stone, that is going to be just the same thing all the time. So we denote the complement as A with a little hash mark there, and what a complement of a set is going to be all elements from the universal set that are not in our original set A. I know it sounds a little confusing, but we're going to do some examples and it's going to be much clearer. So we have our universal set here is defined as these numbers, set A these values and set B these values. So what's going to be the complement of A? That's what it's asking for. We're going to look at this set and we're going to take all these numbers out. So it's not 1, it's not 2, we can have 3, can't have 4 because it's an A, we can have 5, can't have 6, we can have 7 and 8, cannot use 9 and 10. So that's the complement. Okay. Basically, if you think about this, if you take a set and its complement, the union is going to give you the universal set. Okay. What about B? Let's try that. So we can use 1, we can use 2, can use 3, and you can use 4 and 5, and you can use 6 or 7 or 8 or 9, but you can use 10. Alright. And now you can do some operations with sets. So A complement union B. So it's this set and that set union. So we're going to have 3 and 5 and 6 and 7 and 8 and 9 and 10. Here we are asking to find the intersection of both complements. So we're looking for common elements. So we can use 1 or 2 or 4. We have 5, and that's the only number that they are going to share in common. I do want to mention this because sometimes when you look at in some textbooks or even online, sometimes they use this notation here, which is like a superscript C. Kind of looks like an exponent. That's also a complement. Right, let's move on. So what I want to show you is help you visualize what a complement of a set is going to be when you view it. So in this case you are going to have a universal set and then 2 sets A and B, or you can have more than that, but it's not really the case here. So what's a complement? It's all the elements from the universal set that are not in A. So when we shade this, we're going to shade everything except what's contained in A. Okay, so it's going to look like this. Go with this. Okay, so all these except what's in A. Right? And you can probably understand that for the complement of B, it's going to be all the elements except those that are in B. So we're going to shade everything except what's in the set B. So everything on the outside of B, but inside of U. I do want to mention a couple important facts that you should know. If you ever do a set, and it doesn't matter what, for all the sets, if you do a set and you're going to do union of that with its complement, you are always going to get the universal set, because that's just how they are. And right here, always. And then if you ever do a union, a set intersected with its complement, you will always get an empty set, because of the definition of the complement. And so these are very important things to know. All right, let's move on. So again, we have some problems here with the parentheses, just like you should know by now, the order of operations is going to take place. You always do what's in parentheses first. When you have to do these problems, I always recommend writing all the complements that are involved here. We do have to have a complement of A, B, and C. So the complement of A is going to be, this is from 1 to 10. So the complement of A is going to be 1, 2, 3. We're going to have 4, 5, 6, 7, 8, 9, 10. The complement of B is going to be 1, 2, not 3, 4, 5, not 6, 7, 8, 9, 10. And the complement of C, there was a complement, is going to be everything except 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7. Right? It just makes it easier, a lot easier when you do it this way, when you actually see the elements. So A intersect with B complement. So this is A, this is B complement. What do they have in common? Because just 1 and 2. Okay, so here we should do the union first, union of A and B. So the union of A and B is 1, 2, 3, 4, 6, 7, right? Combining these two sets, and then you're going to do the intersection with C complement. So what do they have in common? 1, 2, 3, 4, 6, 7, right? Okay, A complement intersect C complement. So here's A complement, there's C complement. So we're looking for common elements, right? So what do we have here? We have 4 and 5 and 6 and 7, right? And for the last problem, just like I did here, let's do it in steps. So this is going to be a complement of A, union. Here let's figure out what the intersection of B and C, B complement and C complement is. It is going to be 1 and 2, 3, 4, 5, and that's it. 1, 2, and 5, right? These are the only elements that they have in common. And now you do the union of that with the complement of A. So that's going to give us 1, 2, and then 4, 5, 6, 7, 8, 9, and 10. Okay. A few more examples here. So this is where it gets very, very important, because there are some problems where you have to figure out what's in each set based on the Venn diagram, and you're going to see a problem that looks like this. So there are some numbers written here and there. So here's what we need to understand. What are the values that are in set A? First of all, set A is everything that's inside circle A, so it's going to be 1, 2, 3, 5, 6, and 9, correct? What are the elements in the B? That's all the elements that are contained inside B. That is going to be 2, 3, 4, 5, 7, 8, and 10. What are the elements? So this here is our universal set. So everything inside this circle is going to be part of the universal set, right? That is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Everything, inside, outside, just has to stay within that box that represents the universal set. Right? So what's in the complement of A? In the complement of A, you're going to have everything inside U except what's inside A, right? You can also do that. So what is it going to be? It's not 1, not 2, not 3. It's going to be 4. It's going to be not 5, not 6. It's going to be 7. It's going to be 8, not 9. And it's going to be 10, and 11, and 12. What's the complement of B? Well, it's everything that's not inside B. So in our case it's 1, not 2, not 3, not 4, not 5, 6, not 7, not 8, 9, not 10, and then 11 and 12. Now last couple more things now that we have everything here. A union of of A and the complement of B. So here's A, here's complement of B. Union means you're combining everything, right? So let's see. It's going to be 1, 2, 3, 5, 6, 9, 11, and 12. This is the intersection of A and the complement of B. So what do they have in common? Here's A, it's complement of B. Right, so it is going to be 1 and 6 only, correct? And that's how it is. I hope this helps.